Hello, Algebra. We didn't get Ethan's video in time, so I guess you're just stuck with me. So we're going to be working on section 8.1, which is multiplication properties of exponents. This is not a really flashy video for the next, I'd say, 2 to 3 sections, but exponents are really interesting and really important and give us lots of applications. But we don't really get into the cool applications until we've learned the basics. So we have to master the basics, and then we can move on. So first thing we got to remember with all exponents is the order of operations right here. Okay? At the very top of the order of operations were parentheses, meaning that's what we did first before anything else. Next in the order of operations were exponents. After parentheses, we did exponents. Then we moved on to multiplication and division. And then from there we went to addition and subtraction. You might have seen it written as the op-hop, where we did the PMD. There it is. Like that. If we split that up into op-hop, obviously my artistic ability is fantastic here. So that's what op-hop looked like. I prefer this method here, working our way down on the left. Okay, what's important though is when we're working with exponents, everything's going to take a step down. If you see parentheses, or if you see, sorry, not parentheses, you see exponents, that means that we have to step down into multiplication. And if you're working with multiplication, that means you step down to addition. And if you're working with division problems, that means you step down to subtraction. It'll make a lot more sense once we get into the examples. But remember the phrase step down. Okay, that'll be a big help with us. So let's look at some of these problems. So first of all, we have to remember that 5 cubed is actually just 5 written 3 times multiplied together. It's just 5 times 5 times 5. Well, if we multiplied that as one term here, and then the 5 to the 6th as the other term, 5 times 5 times 5 times 5. I should have picked a smaller example here, but it's 5 times 5 times 5 times 5 times 6 times. We now realize that we have 2 terms that are multiplied together, which actually means the shortcut is 5 to the 9th, because we notice that we have 9 down here. Well, the shortcut is pretty easy. 3 plus 6 is equal to 9, and we have to ask ourselves, why does that work? Well, the reason why it works is pretty simple. We have this term right here sitting in the middle, this multiplication term. And if we went back to our order of operations, which is what we were working with before, multiplication has to drop down to addition. Okay, so we're working with multiplication problems, then they turn into addition problems. Well, if we used our calculator and we wanted to know what 5 to the 9th was, we would go 5 caret to the 9th, and that would give us 1,953,125. Let's see if I can. 1,953,125. Okay, but in algebra, this answer with the exponents is much more powerful. It's smaller, it's easier to read, and it shows to me, the teacher, that you didn't cheat on the assignment. So let's take a step down. If we did -2, and I could put parentheses around that just to make it look a little simpler, -2 times -2 to the 4th, we can use the same nice exponent rule. We can step down into addition. The problem we have, though, is that we don't know the exponent on -2. So if we have a number floating in space, like -2, we have to ask ourselves, what's the exponent on that? And the truth is, it's an exponent of 1. If there is no exponent, the exponent is always 1. So from here, we can do the nice, easy shortcut policy. We're in multiplication. We have to step down to addition, and we end up getting the exponent of -2 to the 5th. Now this one I think we can do by hand. We get -2 times -2 times -2 times -2 times -2. -2 times -2 is 4. 4 times -2 is -8. -8 times -2 is 16. And 16 times -2 is -32, giving us our answer of -32. And the reason why I has us working this out by hand is pretty simple. If we go to a calculator and write in -2 to the 5th power it gives us an answer of negative 32, which seems pretty interesting. Okay, actually it doesn't seem interesting, it seems very obvious. Well, if we change this to negative 2 to the fourth, we know our answer is 16 because we take one of the 2's off and we're left with that. So let's type in negative 2 to the fourth, and we should be getting 16. Uh-oh, something didn't work. Okay, and the thing that didn't work is very, very simple. This negative sitting out front is not being read by the calculator. Therefore, when you're doing exponents, just like when you're doing fractions on your calculator, you better be doing parentheses. Negative 2 in parentheses raised to the fourth is positive 16. And there is no reason in the world that you shouldn't be able to do these by hand. Okay, they're not difficult, they're not challenging, and they don't even take that long. All right, so let's go back to another example here. We now have x's. X to the squared, x to the third, and x to the fourth all multiplied together, meaning we can take a step down and change from multiplication to addition. 2 plus 3 plus 4 is x to the ninth, and that's our answer. Alrighty, let's have you try these on your own. So let's pause the video and see if you can give these a try. Okay, so we're back. We'll go pretty quick. 4 squared times 4 to the third will be 4 to the fifth power. Okay. Negative 3 squared times negative 3 to the first would be negative 3 to the third power. And this on the bottom will end up being n to the 10th. These are what we call exponent notation. If you wanted regular notation, which the book will sometimes ask for, 4 to the fifth is 10,024. If there's a number that's over about 10,000, or 1,024, I would use your calculator. But this one here, you can go negative 3 times negative 3, which is 9. 9 times negative 3 is negative 27. There you go. So, now the next one. We have a number raised to an exponent, meaning if we went back to the beginning of our problems, we would see that exponents drop down into multiplication, which means this here, the reason why this works is because we would do 3 times the third, parentheses, 3 to the third, because this parenthesis, this 2 here, means that we're getting 2 of the entire term written down. Okay? Well, if we did the addition method that we had just done, we would get 3 to the sixth. Well, we notice 3 to the sixth comes from stepping down. Exponent on the outside means we step down to multiplication, and we multiply them together. This next one here, p to the fourth raised to the fourth, exponent, meaning we step down, we get p to the 16th. And the last one here, negative 3 to the third, would be negative 3 cubed, because this is a 1 on the inside, and we stepped down and multiplied 1 times 3. This here, we would do negative 3 times negative 3, which is 9, and 9 times negative 3 is negative 27. So if they ask for regular notation, not hard there. Alrighty, so I want you to pause and give these a try. I would like no regular notation, only exponent. So we're back. Exponents means we step down. 4 to the fourth raised to the third is 4 to the 12th. Negative 3 to the fifth raised to the second, we step down to multiplication, get negative 3 to the 10th. And n to the fourth to the fifth becomes n to the 20th. All right? Last section here. These are, if we have multiple terms, okay, this is like the distributive property. This 2 needs to get distributed into each of these terms, once again stepping down. Negative 6 is negative 6 to the first, 5 is 5 to the first. So this becomes negative 6 squared times 5 squared. Negative 6 squared is 36, times 5 is 25. And if we multiplied 36 times 25, we would get 900. This could also work if you did on the inside of the parentheses first and did negative 30 squared is 900 as well. So the shortcut is really nice that we just learned when you're dealing with stuff like down here, exponents. This 3 needs to get distributed into each of these terms. Okay? So 3 to the 4 would have to be 4 raised to the third power. Y raised to the third would have to be y cubed. And the z raised to the third would be z cubed. This 4 cubed would be 4 times 4, which is 16. 16 times 4 is 64. And we would get 64 y cubed z cubed. Okay, this y cubed z cubed is just our exponent. That's all that means. There's nothing else attached to it. Okay, so it means these are terms that are all just being multiplied together. Okay, this one here, now we have to raise this. Now 2 squared raised to this another second will be 2 to the 4th. A squared, b squared. Well, 2 to the 4th is going to be 2 times 2, which is 4. 4 times 2, which is 8. 8 times 2 is 16. A squared, b squared. And that's it there. Okay? I'd like you to pause these and try them on your own. So we're back. So this would become here 2 to the 3rd times 4 to the 3rd, which would be 8 times 64. And 8 times 64 is 512. This one here becomes negative 3 squared times 5 squared, which is 9 times 25, which would be 9 quarters, which would be $2.25. There you go. And the last one is going to be 2 to the 6th, w to the 6th. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. So that'd be 64 w to the 6th. Now, I know these problems seem weird because there's a million possible examples that they could come from. Okay, and the truth is, you're right. I can't think of every possible example. But if we do enough practice problems, we should be able to sneak up and find them. Okay, it'll just take some time. So here's what we got. These long examples of problems are each 15 long. So this you need to get 13 out of 15 right to move on. And this you need to get 13 out of 15 right to get your points for. Okay? So there you go. Ask me questions if you need them. Good luck.